Hello, my name is Smith and I would like to show you how to execute the Nifty Net framework on your Windows computer using a Docker container. First, it's important to know what is the Nifty Net. Uh, Let me show you the web page of Nifty Net just to know what I'm talking about. Well, the Nifty Net is a platform, is a complete platform that to performs CNNs, a convolutional neural network, but particularly for medical imaging. It's using under TensorFlow, and of course it's open source. Also, it has several pre-trained models that you can use to download and execute and evaluate and inference your image here. Also supports several inputs that's very important here in medical image. It's not the classical one to the image for deep learning approach, so you can use several kind of image, ultrasounds, CT, and other ones. Also, it's based on some publication that Gibson only in 2017, so they're very nice. Oh, you have the most common network until this point of the video is 2019, like UNet and BNet and DeepMedic. So you can change also, you can use the different loss functions, and you can create your own loss function and your own metrics here and parameters. So to install this, you can enter on the GitHub page of the Nifty Net, and there is instruction for the installation, and the most easy one is just using the pip tool provided by Python, and you can use the pip install Nifty Net, and that's it. But you need previously the installation of TensorFlow. You can choose the installation of TensorFlow by CPU or by GPU. Also, all the libraries required for TensorFlow, like NumPy and maybe to plotting, to Matplotlib, to the other ones to execute. So in order to avoid to create more instance of or more library installed on your machine, we will use the Docker approach. That is very nice. So first of all, the first is install in Windows. So I am using the classic one. Oh, well, okay, more easy. It's download Docker for Windows. That's more easy. We need to install the client for the Docker from the Docker Hub. The Docker Hub Registry is the web page where you have the different image to be executed. Okay, you need to create, or you need to sign up on your Docker web page in order to download, to push, to pull the image there. So I already have my account. Let me use here my classic password 1 2 3 4 5 6 7 8 9 10. I'm kidding. Okay, no, I get the Docker. There is some important things here that it requires Microsoft Windows 10 Professional or Enterprise. That's very important if you want to execute this. Also, you need to enable the Hyper-V virtualization feature for Windows 10. Enable. That's the most important here. You have to set this in on, because by default is off on the machines of Windows 10. It's only for Windows 10. If you are using some Linux-based machine, that is not necessary. For in Windows, you only have to use the PowerShell and enable this option for hyper virtualization, and that's it. After, maybe you need to restart your computer to execute the change here. Okay, so this one, the Docker Hub Registry, is a place where there are several content. For example, if you want MySQL period there, I have containers that I can download and execute without the need of install all the package. There's several made for some for enterprise or for very well known um, organizations or for just people. For example, I have my account there in Docker Hub Registry and I put a couple of container here. For example, I want to execute, I don't know, Keras. I have some from the people, Keras in Docker for reproducible deep learning CPU and GPU. Another one also you can, so I don't know, Flask. Oh, you can search for several things that you want here. Also, if you're looking for some information about how to use there, then in the internet there are several tutorials. There is an important thing here. With Docker, you have containers that are based on Linux operating system or Windows. In my case, I am using Linux. The Linux is the operating based systems, but in Windows you can select if you want, if you choose the Windows or the Linux. That is the container is executing over that operating system. In my case, it's Linux because I have other people that are working with Linux environment that it works for almost everything, and the majority of people, in my opinion, that is working with with deep learning approaches, so they are using Linux operating system. In my case, I have Windows. That's why it's tutorials how to explain how to do this. So well, here then you have several pre-built image that you can pull and try on your computers without the needing to define and configure by your own. You have all already configured here, and you can select by categories and choose the category that you want specifically without installing anything, just all the executing inside that container. That's a very nice approach. So the first time that you execute this and you install the client, you spend like some minutes because there is starting all the virtualization here on your computer. Okay, when you create an account, you create a space. When the space contains all your repository here and your contribution, well, it's the start that on the profile that you want. So it's like GitHub, very basic in that sense. I have a couple of that with a Keras and Nifty pack. That is a Nifty Net that I create, and we will use this. Okay. Oh, sorry. In this one, I use TensorFlow in that version 1.12, and the execution of all the components on NiftyNet is in the root folder over the main category file here. Okay, then after we skip this installation process, the installation process is performed directly on the client. Where is the client? Oh, I have to start the client, sorry. Docker desktop, this one. I thought that is automatically starting, but sorry. Okay, takes a few seconds, but it's more than a second. Well, all the time seconds, but it's like a couple of minutes maybe to do that. Then in the NiftyNet, there are several models too that we can choose. Those two here are using a pre-training model with the weights already defined, and majority of them have this regression model, for example, for estimate a CT from MRI. So have the paper associated with that. In that case, it's a paper Berger and others, and how to download the model using a command from NiftyNet, and how is the training process, using the training process with the parameters. Basically, NiftyNet is using a configuration file. It's a configuration file that you execute. In that case, the configuration file is the net example ini. So where is defined all the definitions on how many iterations there are, which is the loss function, and other parameters. We can check that maybe where in source code. No, source code. No, okay. Source code. No. If the head here. Okay, this is how the process, how to generate, in that case, error maps, how to generate the output, and all the process. It depends of the which model you select for this. As I mentioned, there are several, well, not several, the most famous model like VNet, GAN. Where is the unit here? Oh, I think the unit is, I don't remember which unit on this one. Okay, when you're starting this, it requires the login and password that you create to download this. Okay, it's running. That's perfect. We go to the settings. Just to check here, you can check that you can check the repositories that you have. I have two repositories, Nifty, Pack, and Keras, as I show you here. That's my two repositories available. And it depends. At the beginning, you don't have anyone because until you create one, and you can switch to the Windows container. In my case, by default, is using the Linux container, so that's very great for now. Okay, in the settings, this is important. Okay, I all the time uncheck this because I don't like the start. This will be very important for some case because he's said that the daemon of the Docker is available for other kind of application to connect with this. Shared drivers. I will share my driver C. That's in order to share files from the Docker container and my operating system. Remember that my Docker container, in my case, I am using Linux containers. So I am in the Windows machine, so I have to share in order to show, because if I want to see, for example, an image, I need to install something on my container on Linux, but it's more overhead about that container, so I don't want that. So I use my classical image viewer here on Windows using Paint, I don't know, just to see the image, and left my container in Linux just to author operation. Okay, apply the change. The advanced is very important because it's the amount of resources that the container can execute. In some cases, you need to execute more CPUs or more memory. All depends. So this is the important file that you can see that my virtual machine file is not really a virtual machine, but it's a hyper virtualization. That's another story. So is Windows. This is a Linux, sorry, and this is my address of this. You can change off those parameters. Okay, great. After this, okay, we can use then the Docker. Docker is running. That's important. That the Docker is running. Okay, you can use the PowerShell or the classic command console. I use the command console because I like more than the PowerShell. This is the console. Okay, so first we can to check how many images we have installed. At the beginning, I think they have one. Okay, yes, I have one image that I created several months ago, but at the beginning you don't have any image created. It's the amount of image installed on your machine. Also, you have something called container. Container are the instance of the image. You can see this like an object-oriented programming approach. So the class, the Docker image, the image of the Docker is a class and a container is an object. So you instance an image and you create a container to execute it. In this case, I don't have any container executed until now. So the first step then is get this container or this image. That's a very confusing name. Maybe I am wrong in the exact works to execute both, but I download an image, this image actually. I download this image and I create a container of that image. Also, I can create several containers for that. We can see this. To do this, we can use the pull command. Just copy it, great, and paste here, enter. That's a bit. Well, in the Docker Hub Registry, you have several, or you can have several labels and tags to know which is the version that you are using. In my case, I use the default tag. This is the last one that I created, and it's downloading. You can see that how the downloading process is very fast, according because it's using several ports. Okay. Well, in that case, this command download my my container, my account to my machine in order to be executed. So when I write the Docker image command, I will see a new one. That's the expected one, at least to know that everything is okay. I don't remember how is the weight of this. I don't remember what is the weight of this. But in the tags, I only have one tag. This last one. Okay, this is the how many is the weight of my image. So you have to be prepared to that amount of to be download here. So the next step after this command is execute. Like in the execution, it is possible to use the Nifty Net executing on that container on your machine using Docker. That could be very confusing, but there's a very nice approach for us. Okay, all the operation that will be executed in the container is inside the container. So if you create a file, the file is created in the container. So you need to share this with your local machine. In that case, this is my local machine. This is my local machine. So I need, okay, I don't like the icons. So I remove this, and this is my local machine, and here's where I will share the information from my container with this machine. So that's important. It's very important that this option will be set at the beginning. The shared drivers, very important. So I will create a folder to share the files that I created from my container, from my Windows machine. Let me call this folder there. Here, this will be my share folder, my bridge folder, my hub folder. That's a name that you want between my container and my machine. Let me come back here. Okay, download newer image for. If I wrote Docker image, this is my new image here. If I wrote the container, there is no container until now. There's no container because I don't execute. I only download, but I don't execute anything. To execute my container, I have to write docker run -i -t and the name of the image. In that case, nifty pack. Okay, I can add the tag, but this is not necessary because this is the default one. In that, oh, I forgot the batch. by default is using only this. I am inside the container and is using the default command shell. Let me exit here, and now I can list which is the containers available. Container, yes, there is one that the command that I start is sh, the shell. This is the name, this is the image executing, how many times was created, and which is the current status of here. Okay, I will execute again, but using in this case a batch to be more friendly, at least for me. This is more friendly. I have my folder home. I can create something. I don't know, a file. There's a file created. So if I list this, I have my file here created. But if I exit of this, I have that in the second container created. It is one. In the most, this one created, and I exit 5 seconds ago. So that's so great. In that container, there is the Nifty Net pack installed. How I can check this? Let me execute again. Also, I can execute this in this way. It's like interactive. Also, the I means the standard input, and the T means like a pseudo TTY, the teletypewriter. I mean, that's the meaning on TTY. So I can execute this. Oh, I forgot again the batch. I can create as many containers as I can. That's the amazing thing here. So I can check that my NiftyNet is installed in root. Sorry. No, I don't remember where it is installed. Media mount. Well, no, let me start more clear. Okay. Then the Nifty is installed. Now the next step is execute. Okay, we're using the quick start. Where is the quick start here? Let me the first page. No, this is the company that's located in London that created this model here. TensorFlow. No one is not here. Website. I don't remember which is the page. Yes, I generally open several tabs to work all the time, so that would be a mess, and also the pop-up message that is okay. I am looking for the documentation. Okay, here, read the docs. Great. I mentioned that the NiftyNet is based on the configuration file, so this link is very important. The configuration file is all the options available to execute this, and is separated as input data, system, network, training, inference, and evaluation. And each one has several options to execute according to your configuration of your network. For example, with the path to search. Also, there are several examples that you can check. Okay, we're gonna start with this one. We will first execute this command, and this command is download a SU model. This is a SU model of a VNet. The VNet model that it will be executed should be, let me check. It's again in the same page that we have before. The VNet is this one. It's segmentation of multiple organs in the abdominal CTs. So this is the paper associated with that, Gibson and more other people. Barrett. And this is the first command that we have to execute. Also the training weight of the network and the example data that you can download here. Okay, then using the Docker, let me execute the same. We can check in that point we have three containers, four. Okay, they're very crowded here. Okay, execute this like el Docker run the image IT, but in that case I want to share my files from the Nifty with my Windows environment in order to see what I am doing. Okay, I have used the -v. This is a volume, is to share my volume for my folders or my folder volume here with my container. In my case, I am using this located in that position data. I want to share this with the located in root. It's just to select something. This is from my local machine on here on Windows, and this is from my Linux based Nifty Net container / root. What is happening here? Batch. It's to know. Okay, now I am running. Oh no, sorry. I don't want to find. I found some mistake here. Oh, I forgot the name of the container to execute. The name of the container here is nifty pack. Great, I am inside this one. Okay, let me put here. Now if I create some file in this folder, okay, that's a very mess here. I can create a folder here, for example txt. It will appear here. If I change something here, hello my friend, doesn't matter, save. On my Windows I can see this on my container. Hello my friend, that's working very good, that's very important. Okay, now it's time to follow instruction here. The first step is download the model 2 from the VNet. When I execute this, at the beginning is downloading the required file to using the NiftyNet framework that works using a Keras under TensorFlow. So here is the folder, important folder, NiftyNet, where we download all the required files to this. It's accessing to the GitHub. In the model 2 is download the required files, in that case the code, the data, and the weights of the neural network, the amount, and let me wait to this finish to check the files that download. Okay, we're waiting. Well, of course you can open another command prompt in order to check this process, like attach a process inside your Docker or create another one container. You can choose there. So sometimes it's important to attach a new process there without closing the current one. That's like a Linux machine works, and you can open several instances of current status, so that works in the same way. Okay, I have timeout. This is not timeout, is about the connection, it's not about the yes, it's a timeout, it's about the connection. The request is not complete. It's not about the performance. Maybe, I don't know, my connection, or is several people or the server there. I don't have idea. Well, let me check, see if I download something here. But yes, I will check that. Let me wait. Okay, now it's downloading the weight, so this is the great. Now I have, okay, let's explore over here because it's more easy, more friendly that using, because I am in Windows, more friendly than the console. If I have the data download is the about the VNet, the abdominal part. I have the CT in a nifty format, the CT and the label. So because I am in on my Windows machine, I can use my tools here. I have, for example, a slicer just to check what is this. The beginning, this is my CT, this is the label, this is the label. I think that is a label about one of the organs, because that's it, the downloading process here is the most told me that it's a downloading multi-organ segmentation, so maybe it's that. I'm sure that is that. Of course, this is all the file that is downloaded, including the weights and the particular format of this. So we're waiting for this slicer, 3D slicer. Of course, you can use any viewers that you want. Also, you can use your own code on Python anyway. Okay, slicer for the CT. The CT. Okay, let me. Okay, let me do the both. What is it? Great. So I have data. This is my label. It's a 3D label of the components from one color. I'm sure that there is some configuration file where is the colors or a comma separated value file that define which color or which index is associated with which organs. And in that case is the whole CT. So the advantage here is I can see the volume rendering process, at least for this. Let me select a preset, maybe this, just to see this. Okay, this is the organs and the labeling is here, and the one is the color for the labels. This is the labels associated. That's very nice way. It's just to check that what is I am downloading here. Okay, minimize this. Okay, this is my data. After I have extension, I have the network, and here is the configuration file, which from my opinion is the core of the Nifty Net to configure anything. Okay, some technical problem here, but no problem. Here's the configuration file. That is for me that is the core of that Nifty Net. So you have the CT label here, and define the sections as I show you in the main web page. That's very important that you have to check that configuration file to know which are the sections available in the configuration file to change and to tune, to perform, to adjust your parameters here. So this parameter, this is the window size, the spatial, this is the some orientation of the data, because it's a 3D data, medical data. It's if you're using some threads, how is the batch size of the network, also for inference and for training, because they are very different here. Inference is once you have all the weights and the network already trained, you have used the inference to know which is the results with my network. This is where is the output of my inference, and the training you can send the loss rate, loss type, number of iterations, and all the parameters. That's a number of classes, the class or number of classes. 9 classes, I mean 9 organs. Okay, great. What else I have when I download? Well, this is the loss function that you can check, you can change, and you can that options. Of course, you have some um, uh, guidance instruction on the web page of NiftyNet that you can how to change that or how to create a new ones using your own um, your own approach to obtain different results. Okay, what else here? Extensions. And the last one is the models. If I open this one, I have the label. Okay, the labeling is 0 to 8, and this is the weights, the model that you created that is using that is already trained for the VNet for this case for the multi-segmentation. So if I open this, maybe it's a binary file. Yes, it's a binary file that have which is the weight of each neuron of your neural network. Great. We come back here to execute the follow steps in the quick start is perform an inference. The inference is about where it's located here. Where it's located here in NiftyNet, extensions, TensVNet, config. Getting this ini file as input, we can decide how to perform this inference process. So you can change this, or in that case, we will use this data maybe as input because it's the only data available here. You can change that, and let me check again. Oh, let me check again the ini. The name is data. Okay, this is the path to search, exactly is in that position, and you can change this. You can change this, and that is enough to know or to test another input. Okay, check that this file name contains CT, file name contains label. That's important to know. Label CT, and you can create another one, another file, your own file, just to test, but you have to contain CT or label on the name. Also, you can change this according that you want this just to be easy. Okay, then execute this, and more according the ini file. According the ini file, it will be an output. Oh, it will be an output in this folder, segmentation output with the inference. Segmentation folder will appear here, or maybe here. I don't remember exactly. This is the reference, the save segmentation directory. Will appear the output. Okay, this is executing the Nifty. It's a Nifty read all the sections inside the configuration file, and according that it create the expected output. Is using the models of the parameter of the model. Oh well, in this case I have some problem about my resources on my machine because it's telling me that the TensorFlow needs more memory. I am excessive 10% of its memory. I don't have exactly how many percentage it requires, is the allocation. Maybe it works, maybe it generates some errors about the space that you need. You only have to change the amount of required memory here in the Docker client. You can change this advanced and change the amount of memory to know more memory. Okay, works. 36 seconds. Clean up, stopping, segmentation application stop. Okay, very nice. It's good. Maybe the output will be models here. Exactly. This is all the output generated. I can modify this one. If I read the generated files, the first one, okay, is the same output here. That is all the track of the logging of execution. This is a comma separated value. This is the file is 100 underscore, and you know that CT means the input, and label means the label associated with that input. Where it's located in that position is 100. That's it. This is the CT, and the label is the same, but changing only the CT by label. Settings inference. This is the inference generated with the init file. This is automatically generated, so you can change anything here, only you can change on the init file. Label normalization is label is from 0 to 8, the 9 classes. The output is inference network. Here is the value is, and output is in this file. In this file, this one, and this file contains maybe a nifty file. Okay, I can use the same slicer just to check. Let me close this. Yes, let me close this in. Let me drag and drop this output just to know which is my inference result. This is my result of my network. Okay, in that case, it's not very nice to see what I'm seeing here. Let me see more. Okay, in that case, I don't have color because the output is about labels from 0 to 8. So the difference between one and another is very, it's not clear to know which is different, but there are different colors on each organs. So let me compare with another one, with the original one, sorry. This the labels. Well, I am using this tool, but you can use another tool if you have to compare. You can see some difference. That's very normal. About this is the result of this, and that's cool. That's great. The result that is obtained. Also, you can change all the parameters here on. You can add your own Python code to improve the result of the Nifty Net network. What happened to this? Okay, now we're posing two of these on the output. Okay, visually that's not very different, but well, you know that how's the result. So the Nifty Net works very well here, and only use inside the containers without need of install anything on the machine. Only the Docker client, of course, because you need that to execute. Also, that if you have this, you can execute your own. Well, to finish this, you have to know that inside your container you can execute also Python as NiftyNet according the documentation that appear here, and play with that. You can play with that and obtain your results without expect so many configuration here. That's the important key here, is that you don't need to install all the NiftyNet libraries and conflicts with your libraries are installed. Of course, you can use a virtual environment on Python, that there is no problem with that, but you need more memory, more disk. In my case, I don't have several space in my hard disk to perform that, but you can use that also. I can, well, if I am in Python, I can use TensorFlow without problem, TF, and maybe it works very well, and create all my variables here using TensorFlow, I don't know, key hide TensorFlow. This will be very nice. Also the sessions, in this session, exactly. Okay, I am using the CPU support instruction. That's what I compiled to use. Okay, that's some error about my configuration here, but this, you know that you can use this without problem here. So that's it. That is everything for this. Oh no, exit. Exactly. That's it for this long tutorial how to use this. Well, I hope that everything work fine when you execute this and try to follow my steps here. So thanks for watching.